Hello, sixth graders, and happy Monday. Today we're going to talk about all different kinds of percent problems. We worked on it a lot last week. On Wednesday, you're going to have your unit test, and I know that you're going to do a great job. And so does Mr. Smiles. Let's jump right into our video. Let's start with a quick do now. Write 31/50ths as a decimal. Well, to write a fraction as a decimal, I can use division. I'm going to divide my numerator divided by my denominator. You may have heard before that when you divide, you always put the bigger number inside. That is not true. You always put the number you're dividing inside and the number you're dividing by outside. Let's divide 31 divided by 50 to find the decimal. Before I do this, I need to list my multiples of 50. Go ahead and list the multiples of 50 on your paper, then enter them on the computer. Now that our multiples of 50 are listed, we can start dividing. Do I start in the ones place, the tenths place, or the hundredths place? I start in the tenths place. How many times does 50 go into 310? 50 goes into 310 6 times. What's 6 times 50? It's 300. When I subtract, what do I have left over? I have 10, and I bring down my 0. How many times does 50 go into 100? It goes in twice. What's 50 times 2? It's 100. When I subtract, I have 0 left over. So my answer is 62 hundredths. Now let's try writing 11/20ths as a decimal. Go ahead and write 11/20ths as a decimal, but before you do, list the multiples of 20. Go ahead and write the multiples of 20 on your paper, then enter them on the computer. Now that you have the multiples of 20 down, go ahead and write 11/20ths as a decimal. The correct answer is 55 hundredths. Now let's convert percents to fractions, which is equivalent to 28%. Well, percent means out of 100. So if I wrote 28% as a fraction, the denominator would be 100. It's 28 over 100. I don't see my answer choices there, so I need to simplify. What's the largest number that goes into both 28 and 100? It's 4. I can divide both by 4. When I divide both 28 and 100 by 4, which answer choice is correct? It's B. 28 divided by 4 is 7, and 100 divided by 4 is 25. Now you try number 4, which is equivalent to 24%. The correct answer is D. 6/25ths. I can write 24% as 24 over 100. When I divide both by 4 to simplify, I get 6/25ths. Now let's look at number 5 and 6. Let's multiply decimals. 28 hundredths times 50. First thing I need to do is count how many digits will be behind the decimal. How many digits will be behind the decimal? There will be 2 digits behind the decimal. Now I can multiply. I start with the number in the ones place. What's 0 times 8? It's 0. What's 0 times 2? It's also 0. Now, I drop my 0 because I'm moving to the tens place. What's 5 times 8? It's 40. What's 5 times 2? It's 10 plus 4 more is 14. Now I can add my partial products. When I do that, I get 1,400. I'm not finished. I need to correctly place the decimal. The decimal needs to have 2 digits behind it. Where should I place the decimal? I should place the decimal behind the 14. So my answer is 14 and 0 hundredths, or just plain 14. Now you try one. What's 35 hundredths times 80. Go ahead and solve that problem now. The correct answer is 28. Check your work with mine. Today we're going to talk about solving mixed percent problems. We'll need to figure out if we need to find the whole, the part, or the percent, and then we'll need to use our equations to find them. Remember, we can use three equations with part, whole, and percent. The first equation says, and write this in the box, that percent equals part divided by whole. To find a percent, we can divide the part by the whole and then change the decimal to the percent. Our second equation says that the part equals percent times the whole. Remember, we can write our percent as a decimal and multiply by the whole. And our last equation says that our whole is equal to the part divided by the percent. So depending on what we're solving for, we'll use one of these equations. Let's look at number 1. 195 elementary schoolers and 130 middle schoolers attended a basketball game. What percent of the attendees were elementary schoolers? So I need to find the part and the whole because it's asking me for the percent. It says what percent were elementary schoolers, so percent is what I'm solving for. How many elementary schoolers were there? There were 195 elementary schoolers. To find the whole, I need to know the number of total students. What's the number of total students? Well, I can add 195 plus 130 to find the number of total students. There were 325 total students. To find the percent, when I know the part and the whole, I need to divide the part divided by the whole. So 195 divided by 325. Set up your division problem now with 195 on the inside and 325 on the outside. First, I need to list my multiples of 325. Go ahead and list your multiples of 325 now. Write them on your paper and then enter them on your screen. Now that you've got your multiples listed, let's start our division. Can I start dividing with 100, 19 tens, 195 ones, or 1,950 tenths? I can start in the tenths place. How many times does 325 go into 1,950? It goes in 6 times. That's 1,950. When I subtract, I have nothing left over. I can bring down my last zero, and my answer is 60 hundredths. Now I need to write that as a percent. To write that as a percent, I need to move the decimal over once, twice, so the answer is 60%. 60% of the attendees were elementary schoolers. Now let's look at number 2. A pair of jeans is on sale for 25% off. The discount is $8. What is the regular price of the pair of jeans? This time I'm looking for the whole price, so I'm solving for the whole. So I know that the part and the percent are things that I already know. What's the part? It's $8. What's the percent? It's 25%. To solve this problem, I need to use the equation. Whole equals part divided by percent. Remember that my percent needs to be written as a decimal, so I can divide the part, $8, divided by the percent, 25 hundredths. Before I can divide, I need to move my decimal to make a whole number problem. I'm going to move it once, twice on the outside by multiplying by 100. So I need to do the same thing on the inside. That gives me a new problem of 25 into 800. First, list your 25s. Now that you've listed your 25s, we can divide. Do I start with 8 hundredths, 80 tenths, or 800 ones? I can start with 80 tenths. How many times does 25 go into 80? It goes in 3 times. What's 3 times 25? It's 75. When I subtract, how many do I have left over? 5, and I can bring down my 0. How many times does 25 go into 50? It goes in 2 times. What's 2 times 25? It's 50. And when I subtract, there's nothing left over. So the answer is that the whole is $32 before the discount. We'll do one more together. 55% of the students on the robotics team are in 7th grade. There are 60 students on the robotics team. How many students on the team are in 7th grade? This time I'm looking for the part. I'm looking for the part of the students that are in 7th grade. So I don't know my part, but I do know my whole and my percent. The whole is 60, and the percent is 55. I can multiply my whole times my percent to find the part. I can multiply 55 hundredths times 60. Go ahead and do that now to find the number of 7th graders. There are 33 7th graders. Check your work with mine. We'll do one more together before you try several on your own. In a survey, 108 students said they liked breakfast tacos best, and 342 students said they liked kolaches best. What percent of students chose breakfast tacos? Well, I'm solving for a percent, so I must already know the part and the whole. What's the part and what's the whole here? The part is 108. 108 students chose breakfast tacos. The whole is 450. I have to add to find the total number of students. To find the percent, I can divide 108 divided by 450. Go ahead and list your 450s now. Now that you've listed your multiples, go ahead and solve the division problem. The correct answer is 24 hundredths. Now write that as a percent. It's 24%. 24% of the students chose breakfast tacos. Now try number 5. 65% of the fans that attended a game were cheering for Bee Caves. There were 78 fans cheering for Bee Caves. How many students attended the game? Well, first, am I solving for a part, a percent, or a whole? What's missing? I'm solving for a whole. Go ahead and use your equation and solve that problem now. How many students attended the game? The correct answer is 120. 120 students attended the game. Now try number 6. A shirt is on sale for 20% off. If the shirt has an original price of $20, what is the amount of the discount? Am I solving for the part, the whole, or the percent? This time, I'm looking for the part. Go ahead and solve for the part. What is the amount of the discount? The amount of the discount is $4. Now you try. There are 7 5th graders and 8 6th graders on the basketball team. There are 65 5th graders and 55 6th graders at the school. What percent of the 5th and 6th graders at the school are on the basketball team? Here you need to add to find the part and the whole, and then divide to find the percent. Go ahead and solve that problem now. The correct answer is 12 5/10%. Now try number 8. In a survey of cafeteria foods, 224 students said pizza was their favorite food. That was 64% of the students who took the survey. How many students took the survey? Go ahead and solve that problem now. The correct answer is 320 students took the survey. Now try number 9. A pair of jeans is on sale for 40% off. The original price is $35. What is the amount of the discount? The amount of the discount is $14. Now try number 10. Another pair of jeans is on sale for 30% off. The amount of the discount is $9. What is the original price of the jeans? The original price is $30. You've done a great job on this video. Now complete the practice page and then do your exit ticket.